Hey guys, welcome back to another video. Today we'll prepare some potassium dichromate from chromium 3 oxide, potassium hydroxide, and potassium nitrate. Potassium dichromate is a useful oxidizing agent, and we'll use it in future projects to make some fun compounds, so it's good to have on hand. To begin, 10 grams of chromium 3 oxide, 8 grams of potassium nitrate, and 5 grams of potassium hydroxide were measured out and ground together in a blender dedicated to chemistry. Chromium 3 oxide can be purchased from pottery supply stores, potassium nitrate can be prepared from cold packs, and potassium hydroxide can be extracted from wood ash. I show how to prepare both potassium nitrate and potassium hydroxide in previous videos. Once thoroughly crushed together, the mixture was added to a steel can and heated on a stove. The mixture was heated to around 500 to 600 degrees Celsius for 30 minutes to ensure everything reacts. Once molten, the potassium nitrate and potassium hydroxide react with the chromium 3 oxide to produce potassium chromate. After the reaction, the mixture was crushed up and 150 milliliters of boiling water was used to dissolve the reaction mixture. The solution was heated to ensure full dissolution and then filtered to remove insoluble impurities. After filtering, the solution was acidified with concentrated hydrochloric acid to convert the potassium chromate to potassium dichromate. Hydrochloric acid was added until the solution was strongly acidic to ensure that any remaining potassium hydroxide was neutralized. In total, 90 ml of hydrochloric acid was added. Hydrochloric acid can be purchased as muriatic acid from hardware stores. After the acid addition, the solution was boiled down to reduce the volume and then chilled to crystallize out some potassium dichromate crystals. The potassium dichromate obtained was still impure, so it was redissolved in a minimal amount of boiling water and placed in a large beaker of hot water to slowly cool the solution and crystallize a pure product. After the second recrystallization, 9.7 grams of potassium dichromate was obtained, corresponding to a 48.5% yield based on the starting chromium 3 oxide. Losses are likely due to the two recrystallizations. Additionally, during the initial reaction, heating in a closed furnace will more evenly heat the reaction mixture and likely increase the yield. Anyhow, I hope you guys enjoyed this video, and I'll see you in a future project. Okay, bye.